Okay, so these notes is about the equation of a circle, and this video is specifically about finding the center and the radius of a circle. So first of all, this is a standard form for an equation of a circle, so this is just a standard form. Sometimes the equation is not written in this form, and we have to ways of rewriting it so we can see it in this form. When it's written in this form, our center is HK, and our radius is the square root of r squared, or just r. So since the formula is x subtract h squared plus y subtract k squared equals r squared, to find our radius, we'll square root whatever that number is. And our center, notice how this has subtraction here and subtraction there. Because of that, we get an opposite sign that it says in these parentheses for our center. So my coordinate for the center is the coordinate hk, where these are x and y values of my center. So that's the standard form, and that's how it works. That's how we use it. So this is how we actually put it to use. All right, so looking here. In this equation, it says identify the center and the radius of the circle, and then sketch the graph. In this equation, my center is at positive 1, negative 3. How I know this is, if that's a negative 1, I know the h value is positive 1. And if that says plus 3, I know my k value is negative 3. My radius is square root of 4, which is 2. So if I apply this graph, I'll start at the center, 1, 0, 1, negative 3. So I'm going to go over 1 and down 1, 2, 3. That's the center of that circle. If my radius is 2, I'm going to go out in all directions 2. It's kind of hard to go out that direction 2 because it makes a right angle. It's kind of hard to measure it. But it's pretty easy to measure it in horizontal distances. So I can go over 2 in this direction. I can go into in the vertical direction pretty easily. And 2 left, and then 2 above. So those are 4 points I know for certain is on the circle. Now a circle is an infinite amount of points, all the same distance from the center, but those are 4 points. So connect those dots in a circular fashion. So I don't want to make straight lines connecting them, make them look like a rhombus or something like that. I want to connect them so it looks like a circle. And that would be the graph of that circle. So I use my center and I use my radius to actually graph that circle. In the second one, here, it says that this is the equation for it, and I can easily find my center. In this problem, my center should be at positive 2, negative 1, and my radius is the square root of 16, which is 4. So I know my radius is 4. So I'm going to start at that point, 2, 1, 2, negative 1. So I'm going to go over 1, 2, and down negative 1. That point is my center. If my radius is 4, I can go over 1, 2, 3, 4. 1, 2, 3, 4. Then go up 1, 2, 3, 4. And down 1, 2, 3, 4. So I got 4 points that lie on the circle. I'm going to connect those dots in a circular fashion. And now I've graphed the circle. It could be better. It'd be better if I use a compass to actually graph it, but that's good enough for now. My next one I use a compass for. Here's my next one. Take a moment. Take a look at number 3. If you think you understand it, hold off for number 4 for a moment, because I'm going to explain what this means without the parentheses. If you think you understand it, pause the video and see if you can find a center and the radius for number 3. So give it a shot now. Alright, so if you gave it a shot, you should have found that the center in this problem was at positive 1, negative 4. And the radius is the square root of 9, or 3. So apply the point positive 1, negative 4. So go over 1 and down 1, 2, 3, 4. My radius is 3. I can go out 1, 2, 3. Then up 1, 2, 3. And over 1, 2, 3. And down 1, 2, 3. Now, truth be told, I really would just connect the dots in a circular fashion like I've been. But just to show, I'm going to use a compass for it this time. So I'm a little sticky point on the center, connect it to one of the points on the circle, and actually try to spin out a circle there. No, truthfully, that's more trouble than it's worth. So connect those dots as a circle as best I can without all that. So that's pretty close. Anyway, so I'll probably ignore that little squiggly line there. But anyway, so that's it. That's the graph. The next one is slightly different. In this one, you don't have any parentheses around the x squared. That means it's really x subtract 0 squared plus y subtract 3 squared equals to 14. Because there's no parentheses around it, that means zero's been subtracted from it, or added to it for that matter, but I'm called subtracted from it. So if I had x subtract nothing, but I still x, so it says x to the second. So I haven't changed my problem at all. That's why I can put a subtract 0 here. So now my center is at 0, positive 3, and then my radius is at the square root of 14. And that is a decimal. So I'd rather try to graph a decimal than that square root. So we'll call that exactly, or roughly. So the square root of 14 is about square root of 14 is roughly 3.74. So that radius is about 3.74. So if I graph that, my center is 0, 3, so that's 0, then up 3. If I go over 3.74, I'm going to go almost a 4. So 1, 2, 3, that's more than halfway. So I'm going to guess it's around there. So this is the point on the circle. And go up 1, 2, 3, then about there. And go over 1, 2, 3, and then roughly here. And go down 1, 2, 3, and then roughly 1, 2, 3, and then roughly here. So if I connect those dots, 1, 2, 3, up. So connect those dots best I can. That's a pretty decent circle. So that's it. Give you more. In this section, it says use the information given to create the equation for the circle. So this said my center was here and my radius is there. I know h, and I know k, and I know r. The formula is x subtract h squared plus y subtract k squared equals to r squared. So I know it should be x subtract 13 squared plus y is going to be subtracting negative 13 squared equals to the radius squared. Now, I wouldn't leave it as subtracting negative 13. I would call that plus 13. And I wouldn't call that 4 squared. I would just call it 16. So this is x subtract 13 squared plus y plus 13 squared equals to 16. And that's the equation for that circle, given that center and that radius. Right? So that's pretty easy to do, to give you a center and the radius. And my next one, it says the center is here, and a point on the circle is here. So I'm going to need more space for that one. So looking at that question, if my center is at, this is number 10, if my center is at negative 13, 16, I know h is negative 13, k is negative 16, and I don't know my radius. I need to know my radius. So in order to finish it, I'm going to rewrite the formula. X subtract h squared plus y subtract k squared equals to your radius squared. So if I plug in the points I know my h. I know it's going to be h. It's going to be x subtract negative 13 squared plus y subtract negative 16 squared equals to the radius squared, which I don't know. So clean it up a little bit. Instead of saying negative, negative, let's call that x plus 13 squared plus y plus 16 squared equals the radius squared. And then, because they gave you a point on the circle, it makes it really easy to find r. They told you h and k, and that point represents x and y. So I could plug in x as negative 10 plus 13 squared plus y is negative 16 equals to your radius squared, which we don't know yet. So if I simplify this, I can find out radius squared by square rooting it all. So this is negative 10 plus 3 is 3. 13 is 3, so that's 3 squared, that's 9. So it's going to be 9 plus 16 take away 16 is 0, so it's going to be 0 equals a radius squared. So 9 equals a radius squared. If you square root the left side and square root radius squared, you get 3 equals the radius. So I know h, I know k, and now I know r. R is 3. So the equation for number 10 is x, I'm going to go here, plus 13. So x plus 13 squared, oh, I need more space in this. X plus 13 squared, and then y plus 16 squared equals to 3 squared, which is 9. So the answer for that equation, if I gave you a center and a point on the circle, is that. I'll give you another one just like it. Well, it's not just like it, it's a lot like it. Skip to number 14. In number 14, they told you a center, so they told you h and k. But what they did not tell you was the radius. They told you the area of the circle. The area formula for a circle is pi radius squared. Since that the area is 25 pi, I can replace that in for the letter a. I can call it 25 pi equals a pi radius squared. That's the equal sign. So to solve that for the letter r, I would divide both sides by pi to cancel out the pi's. Give me 25 equals r squared. Well, you probably know r is 5, right? Because you square root both sides and you get r to be 5. Sometimes they're not nice friendly numbers, so you might square root to get a decimal. But I know in this case r is definitely 5, because square root 25 is 5. So I know h, I know k, and I know r. So this equation would be x subtract 0 squared plus y subtract 13 squared equals to 25. But truthfully, nobody really writes x subtract 0. You probably call it x squared plus y subtract 13 squared equals to 25. You probably simplify the x subtract 0 and just call it x squared. Alright, I got a couple other examples. One deals with writing an equation when you have a diameter, endpoints on a diameter. The other one deals with these tangent lines. I'll say those to talk about in class. That's all I have. Good luck.